All right, let's get going with this face function. I would like to first of all remind you about the amazing push and pop matrix and translate. Here's a push matrix. I'll get to what it is in a second. Here's a pop matrix, and here's a translate. I'll do XY. So what's going on here is it's very much the similar notation. I forget when you do it in math curriculum now. It used to be grade 12, but you probably did it in grade 11 with parabolas, where you translate a parabola. Remember that? Where you can translate a parabola, shift it along the x-axis, shift it along the y-axis. That's called translating. It has nothing to do with translating from one language to the other. It's all about moving something in an XY grid or a Cartesian plane. So that's what this word means. And when I say translate in processing, what I'm saying is I'm redefining where 0, 0 is. So instead of saying, the top, instead of 0, 0 being at the top corner, I can actually change it to move it around in our drawing space. So I can translate it to X and Y. And that means when I call face 200, 100, then 200, 100 becomes 0, 0. So here on out, I can just assume that corner of the head, like the top right-hand corner, or left-hand corner, that's 0, 0. And I can just plan my drawing accordingly. Same happens when I call face 500, negative 200. This translate will reset those numbers to be 0, 0. And then I don't have to think about what those numbers are. I can just always assume I'm drawing my face from 0, 0. And I can move 0, 0 along with these numbers, but I can plan my drawing just assuming 0, 0. So that's what translate's all about. It moves where the origin is, which effectively shifts everything around on the screen. Now, push and pop matrix. So, this would be annoying if you just did translate, they would translate from the previous translation. Remember that the draw function is looped, so it's happening over and over again. So if you were to translate and then translate again and then translate again, you'd keep shifting the location because, we're saying, 0, 0 is the new 200, 100. Well, if we translate again to 200, 100, we'll shift another 200, 100. So we'll end up like shifting along, and that's not what we want to do. We want it just to kind of lock it into a new coordinate. So push and pop matrix basically lets us begin with push matrix, a temporary transformation like translate, and pop matrix then puts it all back the way it was before. So we kind of reset. So push matrix is like, hey, remember your previous settings. And then pop matrix is go back to your previous settings so that we don't mess up other drawing for stuff. Basically, all this translate stuff now can just live inside of the face. It doesn't mess up our other things. Okay, so that's what translate does. It's pretty confusing and complicated, but I think if you practice with it, you'll see what's going on. And you can, of course, call me over or talk with your seatmates about this and get a better understanding as we go forward. All right, so now let's start building the face. So a nice thing about functions is that we can break down our face into further functions. For example, I can say something like hair. I could say something like eye or eye and give it like coordinates. I can say mouth. I actually will need 2 eyes. I can spell mouth. I can give it 2 eyes. One can be the left and one can be the right. Now, when I program this way, when I start with the functions, this is called top-down programming. In the original example, I started with just drawing the shapes. That's called bottom-up programming. So the difference is, at the beginning when you're just drawing stuff is not that big a deal. You might even prefer to do bottom-up programming. But as things get more complicated, top-down programming has a lot of value to it. What we're doing here is we're basically making a list of things we need to do. We're saying, hey, I got to go program some hair. I got to go program an eye function that I can customize to put into 2 different places. I got to go make a mouth function. And then you could then go do these things separately. That's really powerful. What we're doing effectively is taking the face, concept and saying a face really consists of 3 parts. I guess we need the actual like square of the head as well. But it consists of maybe 4 different things to do. And we've broken that task of drawing a face into 4 subtasks. And this is a very powerful concept in computer programming. Taking a complicated thing and breaking it down into several easier, simpler things is a hallmark of problem solving. Sometimes this is referred to as functional decomposition, or breaking down a task into smaller functions. And then also the idea of top-down programming. Top-down programming is when you start with the big idea first, like face, and then you break that into smaller ideas like hair, eye, mouth, and then you go and define what those things are. You code in the hair, you code in the eye, you code in the mouth. As opposed to, again, bottom up, I'll just remind you, because we're all doing the definitions right now, bottom up programming is all about you just start drawing with shapes and kind of puzzling things out with the coordinates. You just kind of start at the base layer. And this is starting from the top ideas. So that's the difference between top-down programming and bottom-up programming. There's a time and place for both, but top-down programming is going to become a very powerful one. We had an experience with that in Programming 11. We called it the mode framework. We broke our games into different screens, which were functions. So very similar idea to the mode framework, but we can use it all over the place, not just in our structure of our games. So I'm going to pause there, come back to the next video, and I'll actually define these functions with you, and we'll see what that looks like, and then we'll try to call face and see if it works. I think that'll be an interesting experience. Okay, thanks everybody. See you in a little bit.